Welcome back. We're going to be talking about hypothesis testing. And in this, we're going to have those same assumptions that we had when we did confidence intervals. These are the assumptions that we had for confidence intervals that will carry through with our discussion on hypothesis testing. So let's look into some of the concepts behind hypothesis testing or ideas, and then we'll get into some of the terminology and then actually doing some hypothesis testing. So once again, with the hypothesis test, we're going to be dealing with a normal distribution or something that's approximately normally distributed, this sampling distribution. And what happens with the hypothesis test is we actually have the population mean we believe to be true or was believed to be true. So we'll have the actual distribution. We'll know the mean. We'll actually know this mean, this value, and we'll actually know exactly where 1, 2, and 3 standard deviations, -1, -2, -3 any standard deviation in here, in our what we're going to be calling, what will be called the null hypothesis. And one standard deviation is sigma divided by the square root of n. Remember how that goes there. And then this value right here is going to be 2 sigma divided by the square root of n if I'm at 2 standard deviations, and so forth. Just like when we were talking about the confidence intervals. So I'll actually know exactly what this value is right here. I'll actually know what it is in the distribution. It's going to be my null hypothesis mean, which we're going to denote by mu naught, and you'll see why later, plus 1 sigma over the square root of n. And I'd actually know what that value is because I'm going to know what sigma is, I'm going to know what the n is, and I'm going to know what mu naught is. And the point of a hypothesis test is we're going to have a sample of size n. And wherever that sample mean lies will let us know if something's happening with the null hypothesis distribution. Anything that is really unlikely to occur means that something might be wrong with my null hypothesis distribution. Because the deal is, we assume a null hypothesis, but for some reason, we either think that the mean has shifted to the right or to the left, or we don't know, it's just shifted. We think it might be shifted. So let's say that I was thinking that my mean had shifted from here, has shifted to the right. And I take a sample of size n, and my sample mean is here, in a place it really shouldn't be, right? That's in a tail end. That's more than 3 standard deviations away. This sample would be considered unusual. So this sample is very unusual in this distribution. We call that statistically significant. So that sample mean is statistically significant in this null hypothesis, believed to be true distribution. So that's kind of the idea behind hypothesis testing. Now, if I had taken a mean, and a mean had been here, well, that's kind of where they should be. Means all should lie within here, right? If 95% of my data lie within 2 standard deviations, if I take a sample mean, it should lie within 2 standard deviations. Generally, anything outside of that is considered a bit unusual and might be telling us that that the distribution really, the mean has shifted. The mean really is here, and the distribution is looking more like that, which would make even shifting further, which would make that mean make a little more sense in this distribution. So unusual means tell us maybe something's happening with our distribution. However, it could actually happen that a mean could be out in the tail end, right? In the normal distribution, there is a probability of that occurring, although small, but it can occur. So what we're going to find out is there's going to be errors involved when we do hypothesis testing just based on the properties of a normal distribution. we're going to say that when we see something like this, we would reject the null hypothesis, but we are in error. That probability, that amount of the time, because I could actually get a mean out there. But I'm going to say that would be so rare. I think it's better for me, or it's more reasonable for me to assume that the mean is shifted to the right than for me to get a sample of size whatever that far out in the tail end. But that's where we can have some error with hypothesis testing. So what happens in hypothesis testing is we have a null hypothesis that we believe to be true. We call this thing the null hypothesis. And I know you read about this. And it looks like this, H naught. It's just a zero, a subscript to H. And what we do is we're going to say something about a parameter. And in this case, I was talking about the mean equaling some specific value. Then what happens is somehow we think that mean has changed. So this is going to lead us into 3 cases, and we call them alternatives. And these alternatives drive the hypothesis test. They're where our eye should be going when we look where the sample is in the distribution. And here's what I mean. So I can either have an alternative that is, I think the mean has decreased from that value, or I could have the alternative of, I think the mean has increased from that value, or I don't know exactly what's happening with it. I just think the mean has changed. So these are the 3 different alternative hypothesis. And we have to get enough proof to prove that these are true. Otherwise, we cannot reject the null hypothesis unless we have sufficient proof to prove either this, or that. It depends on what the problem is as to whether I'm going to do what's called a left-tailed test or a right-tailed test. And this one's called a 2-tailed test. And why is that? Because that's where my eye should go. The null hypothesis is always mu equaling the value. You always have an equality in the null hypothesis. You will never have an equality in the alternative. It's always less than, greater than, or not equal to. Now again, the reason why it is called a left-tailed test is because my eye should be going to the left tail. I'm going to be seeing, are there means in this left tail? And if there are, I will have, we can quantify this, but if I get means or a mean far in the left tail, that'll be enough evidence to support the alternative hypothesis and to reject the null. For a right-tailed test, I'm looking to see if means are in the right far tail. And if it is, I could reject the null hypothesis in favor of the alternative. And for 2-tailed tests, since we don't know, our eyes would either be here or here. If I get a sample mean far into the right or far into the left, I would reject the null hypothesis. So I could say I think that the mean height of this dwarf tree was once believed to be 70.1 inches. But we've been doing some more dwarfing to it, so I think the mean has decreased from 70.1 inches. So what I need to do is take a random sample of these trees, take their average mean, and see how that average mean looks in this null hypothesis distribution. And there were other examples in the PowerPoint, and of course there are many examples in Acrobatic on null and alternatives. So what can happen in a hypothesis test? Well, either you reject the null hypothesis or you do not reject it. We never accept it. We just do not reject the null hypothesis. We just don't have enough evidence to reject the null hypothesis. So these are the 2 results of a hypothesis test. And with that, this is how we're going to find out the different errors that can occur in a hypothesis test. If we reject or we do not reject. And here, based on our test, we did this. In real life, the null was true. The alternative was false. Was not true. The null was false, and the alternative was true. Now, if I rejected the null hypothesis and it was true, I made an error, and we call that thing a type 1 error. If I did not reject the null, I should put the null in there, then there was no error. I shouldn't have, because it was true. Now, if I reject the null hypothesis when in fact it was false, no error. But if I don't reject the null when it was false, we call that a type 2 error. And the probability of a type 1 error is what we call the significance level. And it's got the symbol of alpha. So we're going to talk more in the next video about these errors, and we will work through some problems and start doing hypothesis testing. Thanks for watching.